Okay, so number 7. It says the chain on the Diamondback pulls a 2,000 kilogram roller coaster. So its mass is 2,000 kilograms. Train up a hill. If the train accelerates at 0.5 meters per second, so the acceleration is 0.5 meters per second squared, what is the net force required? So we're trying to find the force. Okay, and we know force equals mass times acceleration. So I'm going to use that formula, force equals mass times acceleration. I'm going to plug the 2,000 in for the mass. I'm going to plug the 0.5 in for the acceleration. And I'm just going to type that into my calculator then. 2,000 times 0.5 is going to give me 1,000. Good. And that's going to be kilograms times meters per second squared, which is going to be the same as a Newton. So that's just going to be the same as 1,000 newtons. So 1 Newton is the same as kilograms times meters per second squared. So you can replace that with just a Newton. Newtons is how we measure force. So as long as you keep your mass in kilograms, your acceleration in meters per second squared, when you're finished, your force should always end up in newtons. Okay. That was number 7. Number 8, we already talked about. You're riding a carousel and you feel pushed outward. What type of force is responsible for this sensation? That's the centripetal force. That's that outward pull when you're going in a circular motion. Okay. Number 9, a roller coaster at the top of a hill is not moving. What forces are acting on it, and are they balanced or unbalanced? Okay, so it's at the top of a hill and it's not moving. First of all, do you think it's balanced or not balanced? Yeah, it's balanced. How did you know? It's not moving, right? So there's no extra force pulling it one way or another. Okay, so it's balanced. And then what forces are pulling on it? It's on Earth, right? So what do we all on Earth have pulling on us? Yeah, so it's going to have gravity, and if gravity is pulling it down, what force is pushing it back up then? Good. Gravity and normal are the ones, and they're balanced since it's not accelerating in one direction or the other. Okay, that was 9. Okay, number 10. If a person has a mass of 60 kilograms. Hey, you guys, I'm going through these. You guys should be paying attention and not watching YouTube videos.
Yes, ma'am.
Okay, a mass of 60 kilograms. What is the gravitational force acting on them while waiting in line for the beast? So we know our acceleration due to gravity is, we just use 10 meters per second squared. Okay, because we're on Earth. And then we're trying to find the force. So we're going to use that force equals mass times acceleration formula. And we're just going to plug the right stuff in the right places. I'm going to plug 60 kilograms in for my mass. I'm going to plug 10 meters per second squared in for my acceleration. And then when I multiply that, that's going to give me 600, and my units for force are going to be newtons, which is the same as 1 kilogram meters per second squared. That's a newton. Okay, so that was 7 through 10. Michael, get your work done.
Yeah. 4 minutes left, and I'll get it done. Just darling,
Okay.
what did you get for 6 and 7?
I'm not gonna go back to it, but I can show you later. Okay.
I have the.
Are you okay with that?
I have the setup written down. I just need the answer.
Oh, well then do it. Or you can like look at it later. Okay, people still need this up? For once? Twice? Okay, here we go. 11 then. 11. A Mystic Timbers car has a mass of 500 kilograms and is at the top of a 30-meter hill. So we know our mass is 500 kilograms. We know that the height is 30 meters. What's its gravitational potential energy? We know gravity pulls at 10 meters per second squared. So we just have to put the right stuff in the right places. So our gravitational potential energy is going to be the same as mass, which is 500 kilograms, times gravity, which is 10 meters per second squared, times height, which is 30 meters. And then we just type that into our calculator. 15. What is that? 15. 1, 2, 3, 4 zeros. Is that 150,000 when you type that in, maybe? And potential energy, the units for that are going to be. Did I put it up there? I didn't. It's kilograms. It's supposed to be kilograms times meters squared per second squared, which is going to be the same as a joule. 150,000 joules. Is it 150,000 when you type it in?
I think.
Okay, I think it is too.
Yeah.
Okay, cool.
Yeah, I got 150,000.
Okay, great. Okay, 12, as the car goes down the hill, its potential energy is converted into what type of energy?
Kinetic energy?
Yeah, good, it's kinetic. It goes from stored energy to moving energy. So potential to kinetic. Number 13, when the Adventure Express comes to a stop, its brakes use friction to reduce its kinetic energy. What form does the energy mostly turn into?
Thermal energy?
Yeah, thermal, because it starts getting hot. Thermal energy. That's 13. Oop, saved by the bell.